Perfect. Well, who would like to kick us off this week?
That's pretty easy for me. I got nothing. I'm just going to listen. Nothing to report.
Okay, fair enough. Thanks, Dom. Thibaut is next to Dom.
Yeah, hello everyone. Yeah, not much on the SimPEG side, but I just want to mention that, like, and it's just like up to you, but I succeeded to make the request for an audience to my defense, but it's limited to like something like 10 people, and it's on invitation only. So if if you wish to be here at the actual defense, let me know, and I will put you on the invitation list. But I just want, yeah, but it's completely like voluntary and up to you. But I just wanted to let you know that that was a possibility if you really wanted to do that. But yeah, it's
When is it?
It's on sorry.
When is it?
It's like Thursday the 17th. So it's like in 8 days.
And what time, Thibaut?
At 10 a.m. And if yeah, and I need to know by Monday at the latest. If because yeah, like it's invitation, and it needs to be done like minimum of 3 days before the defense.
And coffee and donuts will be served.
I can send you like emoji of coffees and the donuts. Yeah. That's pretty much the whole I can do.
Perfect. Thanks.
Yeah, that's yeah. Otherwise, I was just like doing readings.
Excellent. Sagi.
I'm pretty much same as Dom. You're just gonna listen. Yeah, nothing. Still quite busy here. Just amazing. Yeah, I really want to do this simulation update with 1D and 3D codes. Yeah, well, hopefully I can do it sometime next week or something like that.
Sure.
It's just a bit of it's a bit busy with just finalizing this project. So yeah, I still. Luckily, I had a chance to work on 3 different pilot studies. So I had a chance to sort of like act as an end user of all the acquired data and see what we can do. So it's kind of exciting, but it's a lot of work to go through all the data, and all data has different structures. And but I'm looking forward to packaging that up for the next month or so, and yeah, and then plugging in SimPEG and make more use of it for other people. So that's most of what I'm doing, but nothing really particular relevance today.
Fair enough. Thanks, Sagi. Actually, Dom, one thing that popped in my mind: when is the SEG workshop? I wanted to make sure it doesn't overlap with the machine learning one I'm supposed to be at.
I'll dig it out once.
Okay, thanks.
I have a feeling they're both on the Thursday.
Probably. Yeah. Well, we can sort that out. Dieter.
Yes, similar to Dom and Sogi, not SimPEG-wise. I was mostly looking into real data, which is something I don't do too often. And the first time, I think it's similar to data as Sogi usually has, just it's EMGS data. So it's they have one line of source and the many receivers on the bottom, and then they bin it into many source positions. I guess that's similar you do in airborne, just in the marine case. So you have awfully a lot of shot positions actually, which is sort of interesting. And it's interesting for many reasons. These are data from 2007, which is still kind of the very, well, early-ish for marine CSCM boom in the oil. But even though it's kind of old data, I'm surprised that they look quite nice. So we're very interested to see how the inversions will get out of that. And other than that, the paper that is finally shaping up, and Lindsay handed in all the things as well, so we might get there.
Great, great. Lindsay, did you like I don't know, like did you have any improvements like on that accuracy stuff?
I stopped messing with it because it's one of these things that you can
Good
spend
choice.
infinite amount of time fine-tuning a mesh. So I went with your suggestion, Sagi, of just using the tensor mesh for that.
Well, and in the modeling, we saw that there are things we simply can't do because I think the EMGS software they use, it does internally some stuff with the bathymetry that we don't know.
Yeah.
So we cannot actually exactly reproduce it specifically where the receivers are very close to the stepped bathymetry of the model. So I'm pretty sure they used there the actual bathymetry and did some finer meshing internally without the user knowing. The ones who publish the data, they're not aware of that, I think. Yeah, so the fun of reproducing commercial software results, I guess.
Yeah, but for that one, I used the Octree mesh, and those results actually look pretty comparable. I mean, I think our errors are probably slightly higher than the others, but not by a significant amount. So, and that was kind of a fun like mesh building example. It would be cool to get some utilities around that, because what I did is basically from the computational mesh that they used, which was like 9 million cells, computed derivatives and to figure out like where the surfaces are, and then threw those into their refinement to sort of build up the mesh. So it actually was reasonably straightforward, which is kind of cool.
That's smart. It reminds me of something that I wanted to work on, right? To be able to use the basically do a coarse inversion and then do exactly what you said, right? Copy gradients and then refine the tree and then keep iterating like this. So we get the basically boundaries really well defined.
That would be cool.
Yeah. So machine learning is Thursday and SimPEG is Friday, so no conflict.
Excellent. Joe.
Yeah, sure. So let's see, we had that little bug thing on Friday. But if you spent the time focusing on discretize, for those who weren't here, just kind of going over some stuff, trying to reorganize, going through some old stuff. As part of that, we decided we're going to look at restructuring it a little bit, like improving some of the PEP8 names of the modules, moving around where they live. I've got like a kind of working document of what I think would work. And I'll drop that in here into the notes, so you guys can look at it and add stuff, whatever you'd like, or just think about it. As part of this, I would also like to go through and update PEP8 names for functions and properties. That'll be a big update. I know it's something that we've taught that has been discussed, away from the camel case. More PEP8 friendly names. I'm in favor of that. I'm not sure if anyone else is. I mean, it's a kind of a fundamental change in the way the code works. Obviously we'd keep the other stuff around for a while, but start moving towards those in the future. Is everyone on board with that as well as part of this kind of restructuring?
Can you repeat, Joe, man? I zoned out for a sec. What do you want to replace?
So I would like to restructure, we'd like to restructure where the modules live as well as their names. So it shouldn't really affect how most people import a tensor mesh. So discretize.tensor mesh would still be like the name of that and where it would live as far as somebody importing it. But we're doing stuff to simplify the structure, the code like the source code itself, I think, at least reorganize it a little bit. So it's not as all on the front page of the thing as possible, just to kind of make it a little bit more clean that way. And then renaming those modules to PEP8 style names. And then also, I thought it'd be appropriate, like I said, to rename the functions to PEP8 style function names and properties on meshes.
So camel case for functions, uppercase for,
not just,
sorry, snake case for, yeah, sorry.
Most of the stuff right now is just kind of camel case. And ideally that should be just the meshes, or just the classes, right? The class objects should be the only things that are really camel case. Everything else essentially follows the whatever underscore for space, lowercase.
Snake, yeah, whatever it is.
Yeah. Everything else kind of follows, should be following the snake style.
One question, and I don't think we have to address this right away that I have, but is, do we want to keep around sort of the shorthand version of things like NC for a number of cells, NEX, NFY, those sorts of things?
Mm-hmm.
Yeah, kind of.
I think what I would like to do is look at some of them on a case-by-case basis, and does this make sense as it is? And if it does, we can leave it. Because there are, like, there's certainly cases to leave some of those.
Yeah, I like the ability to leave that number of cells, like HX, some of these things that are just really tiny and short to call instead of having something really, really long, because we call them so frequently for things.
Right, and I completely understand that, I get that. So there's certainly cases to be made for each. That's why I think we should look at some of these properties on, you know, case by case and see if, okay, should this be renamed? Like, okay, the like cell grad operator right now, I could simply see renaming to cell underscore grad, like all over, something like that, right? It's still short, sweet, you know exactly what it means. Yeah. Just kind of making everything more uniform is what I'd like.
That sounds good.
Other than that, I've still been trying to figure out why the tests are failing on Travis, and I can't for the life of me figure it out. So I don't know what's causing that seg fault. I tried to like reproduce it on my own system in the same sort of environment. So if anyone like if everyone could just try, start up a fresh conda environment, follow the same install scripts that are in the Travis file line by line, get your environment set up the same, and see if you can run the test that's failing.
Can you put a link?
Yeah, see if you can run the test that's failing and see if it reproduces your error locally. Reproduces that seg fault locally. If you guys could do that, I'd really appreciate it, because I cannot get it to reproduce locally.
It is tested in a Linux machine, right, Joe?
Yeah, it's tested on a Ubuntu image.
Okay, great.
Yeah.
Yeah, I'll also try on Ubuntu machine.
Yeah, like the idea. What I'm saying is take it, install it as a fresh conda or a new conda environment. Like it doesn't have to be full things. Make sure it's a clean conda environment you're installing everything into, and then follow those steps.
Okay, sounds good.
I'll get a link to that test. And I can also, I guess I can post some instructions on how to, you guys need how to actually run that specific test that's failing, like the same. I can pare down all the commands needed if that would be helpful. I don't know. If you guys are like, okay, just run these commands after you get a conda environment set up.
But like it is basically just following the YAML file, right? Travis.yaml file. Right?
Yeah.
See.
Essentially.
Yeah, see if you can get the same error.
Yep.
Okay.
Let's see, this is. It's the FDEM or test EM FDEM forward It's just seg faulting on Travis, and I'm not sure why.
Okay.
Yeah, that's odd. Okay.
The link to the most recent master build is on there, so it just seemed very odd to me that it was passing and then all of a sudden it wasn't, and I'm not sure what changed.
Very strange.
And that, like, it's not that there were any updates to SimPEG, they were just, the last two failed jobs were both just automatically scheduled tests, so they weren't due to any changes in SimPEG. Let's see. Other than that, should be getting a bed soon.
Excellent.
Won't be sleeping on an air mattress anymore. I mean, if anyone has a spare microwave, I need one. I'd be willing to come by and pick it up. And
I heard it gives you cancer. Oh, am I right?
Cool. Thanks, Joe. Devin.
Yeah, well, it's good to see what you guys have been up to. Just kind of looking to jump in, figure out where I can best jump in. And since I've kind of finished off all the GIF tools tasks that I had, I'm pretty ready to devote some time to SimPEG. So I guess one thing I was thinking of continuing is with the EM1D stuff. When I left, I'd been going through the tests, and I'd like to continue on and finish those tests. And I think once that's complete, after a little bit of cleanup, we may be able to merge that into SimPEG and then start to put kind of the finishing touches on that. So we can do all the normal stuff, right? We can do forward modeling and inversion for a single sounding, and we can also do the stitched 1D inversion, frequency domain, time domain EM. We just need to do all the Travis tests. Then I think the other project I was interested in was the MT stuff, and I was wondering, have we been able to do any simulations of the 3D MT problem on a tree mesh? Have we done that, or is it all tensor right now?
All tensor right now.
Okay. I mean, that's still something I can start with, but yeah, I guess I was hoping to maybe put some work in there once the 1D stuff was in, do like the stitched 1D for the MT problem, and then also try and think about those comprehensive workflows, but with SimPEG. So how is somebody going to come in for from I don't know, an organization? They've got some data set, they'd really like to go and invert it, and we give them just kind of the tools and the workflow explanations for each step so that they have a successful be doing. And I guess I wanted to get the input from the group before I really get into something. So I guess out of those, is there anything that you prefer or that you think is maybe low-hanging fruit?
One item that I actually think is not on this list, but would be great to have, and I'd be curious what others think, is in the documentation to get a publications page. Both that includes like all of our publications that use SimPEG, but then something that other people can easily contribute to, and have an easy structure for folks to come in, basically put in the citation, a link, maybe a link to a GitHub repository. So I think like sketching out what that could look like, and maybe taking a look at, like, for example, PyGimli has a really nice page. And just taking a look at what some of the other pages are out there and what are the things that we should include in that, because I think showing where SimPEG is used would definitely be a powerful way to kind of show, what kind of problems people are looking at, who's using this. The thesis that Gannon posted just this past week, like it would be great to have a central place where people can point to and say like, yep, I use SimPEG here, and to kind of get that work out and known. So that would be one thing that I think would be great to have. I don't know what others think.
Yeah, I mean, it sounds similar to like the case histories that we had on EM GeoSci. Maybe not as elaborate as that, but a section where people could post what they were, or put published materials, show how they used it for a real problem. I like it, yeah.
Yeah, and I don't think it needs to be like a full-blown case history. I mean, I think basically just like a couple of weeks, but. Okay. I guess from my perspective, and I'd be curious also what other people think. I think the comprehensive workflows might be a touch early. It might be worth more focusing on like, are there other issues that we can go back and sort of tackle? Because I think we want to think through maybe like a high-level API for SimPEG. And maybe
I
also
agree.
work on like the examples that are currently there, like tutorials.
Yeah, I agree with that. I think before anything could get written up, like some kind of workflow, there's a lot of work that needs to be done to make sure we have the tools to do it. I think maybe the 1D stuff is closest to being completed and is probably the most impactful right now. And yeah, before I did any kind of comprehensive workflow thing, like I still need to actually sketch out how the material would even be presented to somebody looking for it. So yeah, I guess I was gonna do the 1D stuff, and once that's finished, then maybe work with John with MT related things and see if he'd be interested in that. Does that sound kind of good for everyone?
Joe, do you have any other comments or thoughts on other places to jump in?
I don't know. Those are all great spots to look through.
In terms of like using Octree in MT problem, what are like, is that actually running, or what are the challenges?
So right now it uses, for the 3D case, it uses the 1D simulation to come up with a background model, because it uses the primary secondary approach. It has a 1D background model as the secondary, or as the primary source to figure out the right-hand side, and then it goes back and solves for the system. So it's not straightforward how that translates to a 3D Octree mesh, right? I'd imagine we might have to do some sort of local volume averaging cell, possibly, or just get better about actually using boundary conditions in there.
Didn't you, I mean, I guess when you're doing this, couldn't you solve at the boundary using the underlying tensor mesh of the Octree, and then you're going to interpolate that solution onto the actual boundaries of that Octree mesh, and then we already have the mechanics for actually solving the 3D problem, and then we just need to have the interpolation from the electric fields on the mesh to the data. Isn't that sort of the two components, or the three things? Just,
well, the idea is we need to come up with the upscale. It's the kind of upscaling problem. But, usually the cells are really fine near the edges, or at the surface, right? The cells are usually fine at the surface, they get bigger. But as you go this way with an Octree mesh, generally like the cells get wider at the surface. Still, like the cells get bigger and bigger as you go out.
Yeah.
And then the idea is, okay, you assume that the property is constant within the cell, or the field is constant within the cell, or something like that. It has some sort of property within that cell that we would need to upscale.
Yeah, I think I see where you're going with that.
It's
Yeah.
really weird at the edges, and it's. I don't think it would be as simple as just solving it like that and interpolating it. Like we could try it and see how well it would work, but I have a feeling it might not be the best approach.
Yeah, so you're basically you've solved this suite of 1D problems on the underlying mesh, but to actually go in and transfer that solution to the Octree mesh in a meaningful way is actually a little bit more complicated than just kind of.
I would expect something like that, honestly.
Have you talked to Roman? I mean, you might want to connect with. So actually, what is your schedule like tomorrow, Doug? Joe. Do you think maybe Joe would benefit from sitting in on our meeting with Roman and maybe asking some of these questions?
Yeah, I think I think that would be good. I guess the other thing, Joe, I was wondering, are the difficulties with respect to the near surface cells, is that coming from topography, or is that just the way in which the background Earth with no topography is being discretized?
I mean, I feel like it's mostly just the way, even with the background Earth with no topography being discretized. So, like, if you think about how the solution behaves at depth, right, it's exponentially decaying roughly from the surface. So it still needs there's a lot of variability near the surface in the solution with depth, right?
Yeah.
I guess you're always going to have the surface is always going to be on an edge.
Yeah.
At least you know that. So there's no like discontinuity that's actually going within the cell.
I'm not worried about that. I'm worried about how the solution behaves in the cells. Does that make sense to everyone? Like it's the solution is. I mean, it's a huge footprint, right? Everything 1D footprint coming down. So the solution in all of the cells, even no matter how far out you are, still decays very quickly near the surface.
Yeah, my feeling, I thought like even simply like doing a linear interpolation, I thought that might be fine. Like assuming we don't have like big topography, I thought like, because I mean, that's sort of literally what you're doing if you like the primary secondary field solution, you solve 1D problem once and basically use that single solution everywhere in your domain. The problem of Octree, as you go further away from the core cells, you got much coarser cells. But the impact of that coarser cells, although we may have some errors in there, but I guess that impact wouldn't be that large in where you got the receiver location. That's my just guess. Yeah. So I thought as a first shot, just do the simplest interpolation and see if you can get the reasonable result.
Right.
If not,
we have a test example that's very explicit with respect to what we think these other examples and runs with different averaging, and just sort of see how things are going.
Good. I mean, we could. If we solve the problem and then we put receivers on the surface, even out towards where the edge of the out toward the edge of the mesh is, and then we could just kind of compute the apparent resistivity and see how close we're getting, and see. You could test it that way.
Well, I guess I suspect, like what Sagi said, a primary secondary approach, I think we're going to be okay on an Octree mesh. I think Joe's concerns I completely resonate with if we're talking about using boundary conditions to drive the solution. because there, then we actually, the discretization of the boundary matters. But if we compared actually between the two approaches, I mean, currently we only have the primary secondary approach, but if we implemented boundary conditions, that could also be a decent test. Is just a simple example with a block. Also maybe compare with the UBC code. I don't know, Doug, do you have an example in mind?
Not particularly, but starting off with even just a simple, like the block in a half space, and just pushing things in a number of different directions and seeing at what point, the numerics start to break down. I mean, I think that would be interesting, and then, gradually build it up so that we somehow are computing topography well enough, and then try to see how that is affected when we use the octree. Just to get a feeling of where the weak links are in the chain and where you can cut some corners.
I mean, I guess fortunately it wouldn't be hard to overlap like the edges, so where the the solution lives on the edges, right, in the MT case for the curl problem. So it wouldn't be hard to find overlapping edges from the base tensor 1D and just put it at the cells, because all of the edges of the octree cells will still overlap with edges that exist in the base.
Yeah,
so
I have this feeling that once you talk to Roman, you'll find out that the solution is not going to be as like elaborate and crazy as you thought it might have to be, and that in practice something it's a little less complicated actually works pretty well in practice. And at this point we've used the UBC GIF, the Fortran codes for a number of real projects, and the feedback has been quite good.
Okay.
People have gotten very good results, and I've worked through a few data sets, and I'm pretty happy with what it does.
Yeah.
But yeah, I wouldn't be surprised if the underlying mesh is used to solve a host of 1D problems, and then since the electric field is defined on the edges, you just go and find the edges that match on the tree mesh, and then you just define them that way.
Yeah. And I definitely see how it could program, and I definitely see how it would give me decent results near the edges. Obviously, I just have if anything is not living on the edges, especially near the outside, I don't think there's any hope of getting anything reasonable between edges at the core cells that are really far out, which is, I guess, is reasonable. I had one other thought recently. I was looking at the curvilinear meshes, and I know we don't really have too much experience with using them, but in 3D, how are the faces represented in 3D of a curvilinear mesh? Because looking through the code and like how it was trying to compute normals, it seemed very odd, and it doesn't seem like there's like a consistent definition of or like a concrete definition of the shape of a face of the curvilinear mesh. I would expect that it would be like a bilinear surface between them, because it can't be a plane, right? To arbitrary 4 points, it can't be a plane.
Does the mesh construction though allow for arbitrary points? Or do we?
The curvilinear mesh?
Yeah.
Yeah, I mean, it looks at this, you give it nodes, right? You give it locations of nodes, and it's easy to think about in a 2D mesh. You basically give it a grid of nodes in a structured array, and those XY values can be whatever you want, and it'll that's what defines the structure of the mesh, is the structure of that array you give it. And so it allows for arbitrary points. So the same kind of thing happens in the 3D, right? You have a 3D array, and that represents the nodes of the curvilinear mesh. So like looking at things, how the how the normals are defined, it looks like it's like they average or computes like triangulated faces and then averages those 4 normals of a face to get 1 normal for each face.
Oh, okay. Yeah, that detail I'm not. I thought like I haven't actually thought about that. You're right. So yeah, you cannot define a single plane for 4 points.
Unless they're all coplanar,
Right.
right?
Right. That's
So-
a good. And then there's no constraint when you're generating that mesh. So yeah. Yeah. That, I don't know. What I know, like all this differential
to get second order convergence. So whatever we're doing is probably sufficient. But like I said, just didn't seem completely concrete to me looking through it. So I wasn't sure if anybody else had looked at that or thought about that. I know in like, so like reservoir simulators often have the similar kind of mesh structure that they can allow for arbitrary grid points, curvilinear stuff like that. And their surfaces are explicitly bilinear curves on each of the surface faces.
Right.
I think this is one for Rowan. I know that he gave a presentation ages ago where I think he actually had like a 3D thing you could interact with to actually see the structure of the face. So yeah, I think this is one we should ping him on.
Okay. And that was another thought I was thinking about over the weekend.
That sounds good. I will ping Rowan in here.
Dieter, while Lindsay is pinging Rowan, I didn't quite get your problem that you were talking about, but it sounded like you're in the situation where you've got a few receivers and lots of sources and you're trying to contend with that. But in some situations like that, then you can just use reciprocity and have basically your receivers act as the sources. Does that fit into your problem? And B, is that something to kind of follow up on?
I do use reciprocity, yes. It's just, I think when I actually dealt with marine CSEM, I usually dealt with data from PGS, which acquired slightly different than EMGS and had less source position, but with longer source signals because it was kind of a finite source waveform that they got more frequency out of it, but then you had lesser points, at least in the early days. So yeah, it's just the first time I looked at the EMGS. Okay. And it's more about then they do this source binning because it's continuous, the way that they have the source signal, and then that's why I think that it's more like airborne. So then, even though you can use reciprocity, then they don't have the sources all exactly the same, but then as they go from time to frequency anyway, then you can do some interpolation. But yeah, I definitely do use reciprocity. Thanks.
Oh, okay. Well, there is there are perspective. I mean, if you thought about looking at really like a plane that's flying really very slowly, right? And then really you should be taking into account the fact that this plane is actually moving while things are happening, and that definitely has potential, but that's another level of problems.
Yeah. How fast are they actually moving, like helicopter airborne service?
It's 100 km/h.
So much faster than a boat.
It's pretty fast. So even, I think I did some computation at 1 second, I think. So the final horizontal resolution is about 20 to 40 meters. So I think you got like 50 stacks or something like that, more than like 50 to 100 stacks.
Yeah.
So
Interesting.
if you can get really clean data, then I think actually doing the same idea is actually SAR, like interferometric, like the satellite images. It actually used that same idea of you're moving, and by doing so you get better resolution. But I wasn't sure whether you can actually get that for geophysics. Interesting problem.
John, do you have any updates?
Yeah, a few things, I guess. Yeah, I've been playing with the MT still. Yeah, that 1D inversion there is still doing good. We're using it just to QC our stations as we go along, collecting them. We've got about 20 stations going. I did another 2D test with the 3D inversion on a Nepal data set. So there's like 4,000 meters of elevation change. This is massive. And yeah, it seemed to line up. The surface was doing a little bit of things differently than the inversion that the colleague there that I was confirming with. But yeah, I think that was just purely my discretization, and yeah, nothing to be concerned about. He said that it looked pretty much similar otherwise. That, and I've been playing with the solvers a little bit again. I updated my MT simulation branch there. Yeah, something happened in the survey when you defined the survey, and it just wasn't, yeah, it wasn't initiating properly. So now everything's good to go. I don't know if that was with an update after I merged in the new master branch, but yeah, everything's pretty rocking there. I actually found something. I was looking into Dask a little bit more. And so Dask, when you parallelize, like when you set your processes, on a Linux machine, you get a little bit more options. You can actually choose to fork and spawn, and then there's another one. And Windows only has the option to do, I think, just the spawn. And that might be why the solvers are kind of interrupting each other, because when I run the Paradiso solver in parallel with Dask and I use it on Linux and fork it, everything seems to work pretty well, except for when you get to really small values like 10 to the minus 41, then the values don't seem to match if I just run it in serial. But all like anything above like 10 to the negative 20 seem to be like pretty spot on. They're not changing randomly like they were when we were testing it on Windows. So I'm going to look into that a little bit more, see what's going on there. Because even if you run it in serial, those really small numbers, I still get a different value. But they're just so small though. They're like 10 to the e to the minus 50 some or 40 some. But yeah, something else I was going to look into a little bit.
Yeah, what is double precision? Is like 1 to the 38 or something? That's like double float. We're getting close probably to the arithmetic, floating point arithmetic.
Yeah, I mean it's relative to the magnitude of the number.
Okay, yeah, true. Yeah. So yeah, I'm going to run it on a few more tests. That was all MT I was running it on, and it seemed to be producing results that we didn't see with the Windows machines. So that's kind of interesting. Yeah, other than that, just been working on non-SimPEG stuff. Actually, I've been playing around with the Geo5 file there. I was trying to pass octree meshes of big surveys, and it was just taking so long because those files are just so large. But yeah, you throw everything into a Geo5 file, it cruises pretty good. So yeah, I think I'll have that pretty much implemented into Caravelle there pretty soon there, Dom.
Sweet. I'm giving a demo tomorrow, for GeoH5, GeoH5 if you guys want to tune in. 11.
Yeah, I'd be interested.
What time?
11 BC time. I'll post the link.
Cool. Thanks, John.
Please do. Yep.
Yeah. Other than that, nothing too else new.
Yeah, I think I got the same experience. I did not have any problem of like embarrassingly parallel Paradiso solver. So if there's no interaction between workers, I did not have any problem. And maybe I mostly use the Linux machines.
Is that Linux? Okay, yeah. I don't know.
Yeah, I think I did both Mac and Linux. I haven't tried on Windows, so yeah, probably the reason why.
I did it on Mac too, actually, and it was giving me similar results as the Linux. So it might just be Windows related, this problem. Or
could be.
Restricted anyways. Maybe there's a way around it. But yeah, I was going through the DAS documentation, and it said that, yeah, only Linux, and even Mac had one restricted as well as two. But yeah, Windows is the one that you only have the one option, whereas the other OSs give you a little bit more.
But so you were spinning your parties inside the cluster, right? Inside the worker.
Yes. Yes.
Yeah, we're trying to spin the same parties with solver in parallel. That's the issue.
Right.
Actually, that reminds me, I did do some more work on SimPEG, I forgot. So I've broken it down kind of like how Joe did like a mini survey. So now I just break it, or I have a utils in the DC problem right now that it'll break it down by sources, and then you'll have a survey for each source, and then you can make your simulations. And it works. I can I can go and invert, but the thing is I'm a little lost. I don't know where to go from there. Like, how do I bring all those results back, and what do I do? I was thinking I'd have to bug you, Dom, because it'd be kind of like your tile mesh problem, right?
Yeah, exactly. Yeah, let's work on it. That's super. If you have a notebook, let's just work on it.
Nice.
Sounds like you've already done all the hard work, which is splitting.
Actually, it wasn't too bad, but I don't know if it should live in or the utils. I don't know. We can find a place for it, especially if we would generalize it. But yeah, let me push that to a branch, and I'll get a notebook ready for you, and we'll.
I think your advantage, right, is that you have indices for sources, like you know unique sources. When we get a file from the client, it's not obvious like which sources are the same. You know?
That's a good point. Yeah.
Yeah.
I've got a little bit of an edge there.
But yeah, sure, if we can create a utils that's general enough.
Yeah. Cool. Yeah, well, I'll bug you, and if we got time, let's hit it.
That's really exciting, John. I look forward to playing around with that, and happy to sort of be another set of eyes if that's useful at all.
Oh my God, yes, for sure.
Excellent. Doug.
Not much other than what I've said, except that we're going to take another crack at looking through our archives and trying to collect the different data sets that we have. So we've got, a number of potential fields, DC, electromagnetic, of all kinds that have been used on various test sites. Most of them are archived. They're on the old GIF RAID. And I think the goal over the next week will be to kind of get onto that system and just sort of see what we've got, and then kind of bring everything over to Dropbox and figure out which ones we actually can use for testing and distribute, and if there's some that we can use for testing but need to be kept private, just to kind of figure out where we are. But they're great data sets. Most of them have got a number of publications that are associated with them. And so if we can, get those out, then they'd be really great data sets to use for all the, some of the SimPEG testing. So that's kind of the goal. We're going to get together with Devin and Roman tomorrow and just see if we can dig back far enough if all of the drives are around and stuff is still there.
Excellent. That'll be really useful. That'll be really exciting to have access to for SimPEG, especially now that most of the codes are relatively mature.
Well, they'll make nice examples for, if we're talking about having an example for people to, try a potential, just the fact that, here's the data, they've been published before, there's papers that have been written, and here's the SimPEG script to go ahead and do it, and here's a result that you'd get. I mean, I think that'll, between things like that and also the publication page, Lindsay, that you were talking about, those are really kind of important things from the point of view of getting traction and getting buy-in, and for people to easily see, what's available and how to use it. If we can do that, then that'll be a good step forward.
I guess in terms of my updates, I finally sent Dieter results. That's my achievement for the week. So yeah, I mean, if anyone wants to play around with it, we can drop the link into Slack. So there's 3 models. There's a layer, a block, and then the Marlin model. the layer in the block, I ended up using the tensor mesh, although I kept one of the notebooks that uses an octree mesh. I might actually go and update that one because I was able to design an octree mesh that was like better accuracy, just so folks can see that. But yeah, those are there. And then the Marlin model used the octree mesh. And takes advantage of the new volume averaging work that Joe's done. So that's exciting that we'll have that out in a publication. And then what else? Oh, I've been going back and forth a bit with some of the folks at LBL. So Evan Oom, Michael Wilt, and Dave Allenbaugh. They've been looking at doing some casing simulations, but looking at resistive casings, which is kind of interesting. It's not something I looked at all in my thesis. So they've got places where they've got fiberglass case wells that they want to run surveys in. And it's been interesting. One of the things that was kind of, that they were surprised by, and I'm trying to sort of get a handle on this, is that the casing can actually be relatively resistive, like 10 to the negative 6 Siemens per meter. We really don't see an impact of it far away from the well. It's really only if you crank up that resistivity to like 10 to the 7, 10 to the 8 that you actually start to see that. So trying to understand kind of why there's a pretty dramatic shift in there is of interest. So we're kind of playing around with that right now. So kind of interesting to see. Yeah. And I think,
Like that was a resistivity, Lindsay? Like 10 to 6 is the resistivity, not the conductivity.
sorry, yeah, 10 to the 6 ohm meters, or yeah, and
Gotcha,
10 to the 8
gotcha.
ohm meters. Big difference between
Gotcha.
those. So
So you need a really resistive, almost like an air, to see the effect.
yeah. Yeah, so kind of interesting.
Like it's a PVC pipe?
Yeah, PVC, or I think this one's fiberglass. Is that they're doing, I think it's a thermal site that they're monitoring, or no, sorry, it's a carbon capture and storage monitoring problem.
Yeah, I think it's in that where is that, the Calgary, there's a field site.
Cami.
Yeah, I think they actually used the carbon fiber as a
Yeah.
as a casing, I guess.
This one is in Florida, the site that they
Okay.
have in mind. Because at Cami, they actually put electrodes on the outside of the casing, whereas this one, the well's already been drilled, so they don't have that option. So now they're trying to see, like, if we actually put a system inside the well, can you actually see anything outside of it?
Right.
So
Right. And are you like solving a DC problem as a first shot? Is that what you were doing?
they started with the EM problem and were
Okay.
sort of surprised by some of those results. So then we flipped back to the DC problem. And yeah, you can kind of see that basically 10 to the 6, you don't see much of a difference. I suspect, and it would be interesting to play around with this, I suspect it's probably the ratio between probably the ratio between the resistivity of the casing and maybe the inside of the well that matters the most. Yeah.
I think it might be interesting to do this A5 decomposition, Lindsay, because what I can actually see is, like, if you got good galvanic coupling, then you'll absolutely see that impact.
Yeah.
But if the induction is the majority of that response, then you may not see, like, oh, there's no difference whether you put a resistive casing or not. So actually, by decomposing your fields into 2 components, you can actually see what is the major impact and make some intuition. I don't know, just
yeah. No, it would be interesting to see. But even at DC, though, we're seeing that it doesn't, 10 to the 6 is not resistive enough to make.
Okay.
Make it, so.
Okay, then.
That's interesting. Cool. I think that's all that I basically have for updates. Yeah, does anyone else have questions, thoughts?
I've got one more update. I know Doug's been waiting for.
Absolutely.
I've got my beer is primed and ready, so it's ready for delivery.
John!
It's gonna be something else.
I should be in the Kits area on Thursday there. I'll send off to you and Joe. Yeah, I made It's a double IPA, but it's more of like the hazy style. And I found hops that taste like pina colada. So
Whoa.
it's going to be an interesting beer.
I envy you guys. I need to head out, but have a great day, guys.
Fair enough.
Thanks, Dougie. Good to see you.
Sorry. Bye, Zach. So John, are you going to make it till next week, or when is the baby coming?
It's probably going to be soon. I think we'll make it till next week. But next week is, yeah, then it's going to be count down the seconds or minutes, really. So yeah, I'll get it out of this week. I'll get the beer to you, and then yeah, I might disappear for a little bit.
Well, good luck with everything. Both the baby and the beer. B&B.
For sure.
Send pictures.
Definitely will.
Perfect. All right. Thanks, everyone. We'll see
Farewell,
you
friend.
next
Have a
week.
good one. Yeah.
See ya.
Thanks, guys. Bye, Dieter.
See ya. Dieter, did you want to just stick around here?